This is video number 6 for chapter 8 in chemistry. This is on double replacement or double displacement reactions. Now, in a double replacement reaction, you are going to take a compound and it's going to react with another compound. And what's going to happen, if the reaction will take place, they will switch partners and make two different compounds. Now, usually these reactions will happen where the reactants are in aqueous solution. So you'll see the reactants will have a subscript of AQ. AQ just means dissolved in water. Now, what it looks like in terms of a general format is that you'll have a compound, we'll call the first one AX, and the second one will be BY. Now keep in mind that A and B are both positives, and X and Y are both negatives. So you'll notice when they switch partners, they have to switch so that positive stays with negative. So for example, A cannot pair up with B. The only choice A gets to make is to be with Y. So we get a new compound AY, and then BX would form as a result. Now, not every reaction will take place. Not every double displacement reaction will happen. You have to be able to form one of three things. So if a precipitate can be formed, and a precipitate is something we call a solid formed from two solutions. So a precipitate is a solid formed from two solutions. So if you can get a solid out of those two compounds, then it'll happen. The reaction will occur. And we're going to use something called our solubility rules to decide if that will happen. And we'll show you how to use those solubility rules in class. The second reason a reaction would happen would be that a gas could be formed. Okay, so if a gas can be formed, usually it would be CO2, carbon dioxide, or H2S. Those would be examples of gases that could be formed. We don't see that all that often, but it will occur occasionally. And then the last one is if water can be formed. And remember, water is H2O, but in a compound, when you're looking for it, you're looking for H to pair up with OH. Because if H can pair up with OH, you're going to make water. So those are what we call the driving forces, the reasons the reaction would occur. If none of these three things can occur, the reaction overall will not happen. So we're going to try some examples to see if we can put this into practice. And we're not going to do all of them in the video. I want you to try some of them on your own. So I'm going to do the first two with you. So in our first example, we have lead 2 nitrate reacting with sodium iodide. And what we want to know is, will this reaction take place? Now, usually what we're going to be looking for is a precipitate to be formed. You can probably tell just by looking at it, I'm not going to be able to get carbon dioxide or hydrogen sulfide out of any of these things because there's no hydrogen, carbon, oxygen, or sulfur. And water isn't going to be able to be formed because there's no H or OH. So I must be looking for a precipitate. So I'm going to use my solubility charts. Now, for most of you, that is on the blue sheet. Now, what you're going to look for is a solid to be formed. So what I would say is a good strategy is to underline in this part of the in the first compound, what's positive? Well, the metal is always positive. So the Pb is the positive. And in the other compound, it's the Na that is positive. Then underline the negative. Okay, the NO3 is the negative here, and the I is the negative there. Now what we're hoping for is when the two partners will switch, we're going to hope for one of them to make a solid. So let's see if Pb and I were to switch. Let's look at our solubility rules. Find Pb on your list of solubility rules, or if you have the grid version, look for Pb on your grid. Okay, now lead is not listed on the rules, the blue sheet rules that IB is using, but if you look on the list, I is listed, and it tells you here that if you pair up I and Pb, you will get a solid. On the IB rules, it will say that compounds including lead are exceptions to being soluble. So we know that Pb with I will make a solid. Now if we look up Na and NO3, you'll see that they're aqueous. They will dissolve in water. They are soluble. So we know that this reaction is going to happen because a solid can be made. So now it's our job to correctly pair up these ions. The best thing you can do is think of charges. In this case, the Pb has a +2 charge. The NO3 has a -1. And you should know how to figure that out based on our work last chapter. In this compound, Na has a +1 charge, and I has a -1 charge. Now all you're going to do is make them switch partners. So Pb is going to pair now with I. Pb is a +2 and I is a -1, so I should get Pb I2. And if you remember, when we looked up our solubility rules, we saw that that would be a solid. The other pairing would be Na with a plus and NO3 with a -1. Remember, positives always get written first, so we have Na, NO3, and according to our solubility rules, that was going to be soluble or aqueous. So we'll put that subscript AQ by that. You'll notice that the subscripts didn't necessarily transfer. The Pb is still a Pb, but the NO3 does not have a 2 anymore. What we do is we take care of that by balancing the reaction. So if I look, on this side of the reaction I have, on the right side I have 1 Pb, and on the left side I have 1 Pb. The leads are balanced at this point. But for the I's, I only have 2 of them on the right side, so I need to put a coefficient of 2 on the left side, and then I add, that makes 2 NA's, so I come back and I put 2 in front of this. And you guys should be at the point where you can balance reactions without a lot of explanation, so hopefully you can figure out why this balances. Now, I'll do one more example with you, and that it will be the next one. We're going to take barium nitrate and react that with calcium chloride. Now, the positive part of barium nitrate is the barium, and the positive part of potassium chloride is potassium. So the rest must be the negative, the nitrate and the chloride. Now use your solubility rules to figure out if you can make a solid. So we're going to try to pair up barium with chlorine. Okay, so using your rules, do barium and chlorine make a solid? And it says that they are aqueous or soluble compounds. So no solid there. We're going to try to see if potassium and nitrate would make a solid. So if we look at potassium and nitrate, you see that they're aqueous or that they are soluble. And there are no exceptions to that. So this reaction cannot produce a solid. If the reaction cannot produce a solid, and it's not going to produce a gas or water, this reaction simply does not happen. So we just would write no reaction, or NR. So I would like you guys to try the last 2 problems on paper, and we'll talk about those in class tomorrow.